Good morning. This is my first time at doing a screencast for this class. This is chapter prerequisite skills. You'll have a companion note card, that note sheet that you were given at the beginning of the year in class. There will also be an opportunity for you to download them, but for the most part this is what the notes will look like, and we'll try to treat it like you're just in class, except you won't be able to ask questions. Remember, as you're doing the assignments, you will be able to check the completed solutions that I post on Schoology as well, so make sure you're using that, because we will correct online and then hand in our material in class, and I'll state those on the days that we're handing those in as well. Okay, well, let's get going. The highlight and the topics below as they are taught to you in the lesson for the prerequisites. In the overview of Chapter P, you have the basic properties of real numbers, absolute value, distance formula, midpoint formula, equations of circles, slope, standard equations of lines, applications involving linear equations, and solving equations and solving inequalities by algebraic and graphical methods. Now, we've gone a little too far. For Chapter P, Section 1, we will be able to identify subsets of real number systems, correctly use set builder and interval notation. Now, this is important to practice. Correctly use the basic properties of algebra, correctly use the properties of exponents, and simplify algebraic expressions and convert between scientific notation and decimal form. Now remember, the notes for today, we're going to cover 2 days, the 9/16 Tuesday and Wednesday 9/7, not 9/16 but 9/6 and 9/7 as we go on. Now we have the complex numbers, which will be C, and remember they're A plus BI, and imaginary numbers are inside that set, they just don't have an A value on the front. You have real numbers, which will be denoted by this R, or just a regular R for real numbers. Q are rational numbers, and remember, Q for quotient is representing rational numbers, because rational numbers are numbers that are created by dividing one number into another number. Z, the integers set. Z will represent the integer set, and the integers are all numbers from counting numbers and their negative counterparts. Whole numbers, W, will be 0, 1, 2, 3, and on. But natural numbers, N, won't include 0, it'll be 1, 2, 3, and 4. And we have our irrational numbers, I, which equals your R, your real numbers, minus your quotient to rational numbers, your Q, your rational numbers. So that's your irrational numbers, where you have a real number and a rational number subtracted from each other. You can represent it that way. Now, unless specified, we'll be working with the real numbers this year. Sets that are contained within other sets are called subsets. They are denoted with this notation. So from the above symbolism, we have the natural numbers, N, contained inside the whole number set. Natural numbers contained inside the whole number set, because the natural numbers are everything in the whole number set except for 0. But they're also contained inside the Z, the integer set. And please notice how we got this picture set up, which is also contained inside the quotient set, or excuse me, the rational set, which is a quotient, Q. And then we have that contained inside the real numbers, and all that, as we set up, are contained in set C, which is our complex numbers, as we look up at that set above. Oh, I got to get ourselves back here. Sorry. Now, 2 sets that have nothing in common are disjoint or mutually exclusive. Now, they're the cross-section of the set would be a null set if they're disjoint and mutually exclusive. So let's keep that in mind. That's for null set. You might be remembering that from Algebra 2 back in your day. So if you have questions about this, please let me know. Next time you're in class, you can drop me an email. Now, grabbing your calculator, punch in 7 divided by 4. This should return 1.75. This is called a terminating decimal. 4/11 equals 0.363636, but we'll put a bar over it, and this is called an infinitely repeating decimal. Now, the square root of 3 will return a value in your calculator that is an irrational number. It is infinitely non-repeating. as an irrational number. We approximate real numbers with a calculator. Let's underline that as we go through so you guys know what you're filling in on your sheet. It's easier to do. Remember that the calculator response is not always exact. We will be working with exact answers whenever possible. Okay. Now, there's a frustration of working with exact answers. Sometimes, 1/16, 0.0625, you're not really aware of that. The exact that your textbook will work with is 1/16. Some exact answers or repeating decimal answers are tough to realize, so we'll look at it as fractions of 55/27. Okay, like 1/17, as you go through your calculator, 1 divided by 17, you'll get 0.0588235294, and your calculator won't write anything else down. It really is 117647. Okay, so 1/17, and your calculator does this, but really if I bring up a spreadsheet and allow it to open up and start its repeating again, this is the entire value that's repeated in 1/17. Now, real numbers and the points of a line can be matched one-to-one to form a real number line. I know you've seen this before. We start with a horizontal line and match the real number 0 with a point O, the origin. Positive numbers are assigned to the right of the origin and negative numbers to the left, as shown here. So I got my positive numbers to the right, my negative numbers to the left. And when I'm talking about my number lines, I'll talk about, just where it is to the right or left. We got pi, which is representation of 3.14. We talked about square root of 3 up top. Remember, square root of 3 is 1.732058. Well, 1.732058, that negative is down here. Okay, so we have those spots on our number line. How many real numbers are between 0 and 1 in the number line? Well, I'm sure some of you are like trying to think about what I'm getting at, but there's infinitely many, or lazy 8. That's the representation of symbol representation of infinity. The number that we associate with a point is called the coordinate of that point. Okay, so remember, the coordinate is the number of the point. A set of real numbers is ordered. We can use inequalities to compare any two real numbers that are not equal. So we have the order of real numbers, let A and B be any two real numbers. We've got a symbol, A is greater than B. Well, when I subtract B from A, I get a positive value. This is known as A is greater than B. If A is less than B and I subtract B from A, I get a negative value. A is less than B. If A is greater than or could possibly equal B, then when I subtract B from A, I will get a positive or 0 value. A is greater than or equal to B. If A is less than or equal to B, A is less minus B is a negative or 0 value. A is less than or equal to B. The symbols greater than, less than, greater than or equal to, and less than or equal to are inequality symbols, and you've worked with them before. Now the trichotomy property, let A and B be any two real numbers. Exactly one of the following is true. Okay, A is less than B, or A and B are the same value, or A is greater than B. Inequalities can be used to describe intervals of real numbers, as illustrated in the next example. Now, when you were in Algebra 2, you took x is less than 3, and you had an open circle, and you wound all the values less than 3 over here to the left. Okay, and in Algebra 2, in B, you had an interval. You had -1 and 4. -1 was open because it did not have an equal sign, and 4 was closed because of the or equals. This year, we're going to be working with parentheses and brackets. This parenthesis represents the open value, and it's open up to here, and all the values to the left here are included in our set. Okay. A closed value and an open value, this is open, this is closed, between -1 and 4, and that's how we'll represent our values on a number line. The reason we use the parenthesis and the bracket is because we're going to use the parenthesis and bracket when we're talking about our intervals, and it's a little bit more descriptive for us. So no longer will we be using open and closed circles, we'll be using parentheses and brackets. The real numbers, now writing an interval of real numbers using an inequality in Dirot's graph. the real numbers between -4 and -0.5. So I've got -4 less than x, which is less than -0.5. And they're open at both ends, and the interval between them is connected. Here, the real number is greater than or equal to 0. X is greater than or equal to 0. I've got a closed bracket opening to the right, okay, and that has all the numbers that are greater than 0. Now we're going to be looking at this with our brackets later. Somebody put in the wrong type of bracket here. We're going to be looking at this with brackets later and with open and closed values. So this is an open interval, and this will be an closed interval because it's got that infinity in it. There's no definite ending point, so this will be a closed interval from 0 to infinity. Now we'll talk about ways to represent a set. By a given name, we can talk set M, listing all the elements, inside brackets 1, 2, 3, or 4. Listing enough to show the pattern, 1, 1, 2, 3, 5, 8. Now specifying a form or rule in set builder notation is something that we're going to be working on this year. And this next one is set of all n such that n is less than 4. Okay. Then now we also have the interval notation for real numbers only. That'll be half open, and whether the closed bracket's here or over here, it'll still be half open. And this is closed closed at 3, and it's open at 5. Now, bounded intervals of real numbers is what we've looked at in this very last one, in interval notation. Please notice that you have a closed set where you have a and b, two specific definite numbers. You have brackets here and here. It is closed on this interval, which means it's including a and including b. And it'll look like this when we graph it. It'll look like this in our interval notation. Now when it's open, it's not or equals, and we've got a left parenthesis, a right parenthesis, and this is what our graph will look like. A half open set is closed on one end and open on the other. That's where the half open comes from. But we have specific numbers, a and b, that we can stop at and start and stop at. And the same idea for this notation of open and closed, that we have specific numbers a and b. Now describe the interval of real numbers determined by the inequality x is less than 2. When I write it in the set notation, the interval notation that we got above there, we're looking at the idea that it is an open, unbounded interval. Why is it unbounded? Well, let's talk about open first. It's open because we have the open parentheses, because it does not equal exactly 2, and it doesn't equal exactly negative infinity. Matter of fact, because we can't track down how far down the negative side that we start or stop at, it's an unbounded interval because of the infinity. So is the interval open or closed? It happens to be open. I've repeated myself here twice, but that's the end of that question. Now when we're talking about interval notation, negative infinity to infinity represents the entire set of real numbers. So if it's going to be all the real numbers, you can go negative infinity to infinity, and this is open unbounded interval. Now when we're talking about unbounded intervals, we no longer have half open or half closed. It's going to either be closed or open. And notice the brackets. The bracket is located where we definitely have a starting spot, something that isn't infinity. And the open is at infinity. So we got a closed interval. Okay, starts at a and goes to the right, goes to infinity. An open interval, notice the inequality notation, it's greater than, x is greater than a, and it's got an open parenthesis at a and it goes to infinity. Closed, negative infinity to b. Now notice b is bracketed because it's or equals to. Okay, so b is the extent of the set, but it starts way down here at negative infinity, but it's an unbounded interval because of the infinity. And it's closed because of the closed bracket at b. Now the next one is open because of the open bracket at b. Starts at negative infinity, goes on, and x is less than b. Each of these intervals has exactly one endpoint, namely a or b. Now, I want you to kind of cover up the answers on this side and practice which one of these, and just come up with open or closed, half open, half closed, depending on your situation. Just to practice this. This will be on a quiz on Friday, or Thursday for that matter, depending on when you're in class. Now, describe as bounded, unbounded, and open and closed. Okay, again, more practice with the open, unbounded, and x is greater than -2. Closed unbounded, x is less than or equal to 5. Closed bounded, and then we have 2 is less than or equal to x, which is less than or equal to 7. I want to caution you when using interval notation. If the interval is open, don't confuse the interval with an ordered pair. You will notice the difference in the situation you're working with. An interval notation can only be used when talking about intervals of real numbers through a continuum. Interval notation must be written from least to greatest. For example, 4 is smaller than 9, so I'm going to start 4 on the left and go to 9 in my notation here. I would not do 9 to 4. Okay? It makes no sense and would receive no credit. And we're trying to get you to understand this idea of what's going to happen on your AP tests when you finally get there. Example 5, draw a number line graph and write each in both set builder notation and interval notation. All numbers greater than 4 and less than or equal to 9. All numbers greater than 4 and less than or equal to 9. So I kind of gave it away. It's greater than 4 but less than or equal to. I have the bracketed. So in set builder notation, I'm going to say that the set of all x such that 4 is less than x, which is less than or equal to 9. Now in interval notation, I have an open at 4 and I'm closed at 9. Now it's your turn. All numbers less than 4 or greater than or equal to 9. Give it a try. Turn me off and just give it a try using the notation. Okay, all numbers less than 4 and all numbers greater than or equal to 9. In set builder notation is a set of all x such that x is less than 4 or x is greater than or equal to 9. In interval notation, remember I have negative infinity, an unbounded open interval, negative infinity to 4. And then I have a union of a closed unbounded interval from 9 to infinity. Now in C, the set of all Fahrenheit temperatures for which water is in the liquid state. Now we have to assume at 32 it's still liquid, and when it's lower than 32 it'll be a solid state. Okay, so when we're doing this, we're looking at 32 degrees to 212. Now it's important that you recognize that we have to consider the steam. The state of water at 212 becomes steam. So we have a range from 32 to 212. Set builder is the set of all x such that 32 is less than x, which is less than 212. Now in interval notation, that is an open interval from 32 to 212. And please keep in mind, you have to know what the context is to realize that we're talking about interval notation versus just a set of coordinate pairs. In example 6, rewrite each interval notation as an inequality and graph on a number line. Well, the first thing is I like to graph it first. So if I graph this first, I've got -6, it's closed, 3, it's open. So it's kind of nice to be able to take this and do it that way. Now I can go -6 is less than or equal to x, which is less than 3 as my interval notation. Excuse me, I take my interval notation, my inequality notation. Now in this next one, I've got my interval notation, an unbounded open interval, and I can represent it at x is less than -1. And I've got -1 here, and everything less than it is to the left. Now it's your turn for C and D. Now remember, when it's your turn to give a practice, just hit stop and then move on with the next practice and then check your work. Now, ANDs, a set builder notation, or the set of all n's such that 20 is less than n, which is less than 60. The interval notation is 20 to 60. You must use less than or equal to. Okay? Now, you can't do n such that 60 is greater than n, which is greater than 20, because of the order. Please notice the order here. It's got to be 20 to 60. Okay? And you will not ever do this. So remember, you cannot, these are just bad notation. Okay? This is the notation we're looking for when we do these. Now, when we're doing an OR, for the set of all m such that m is less than or equal to -5, or m is greater than or equal to 3, okay, I've got interval notation, and my negative infinity to -5, it's a unbounded closed set, unioned with, because of the OR, an unbounded open set, this 3 to infinity. Now, instead of the word OR, we'll use the union, or the U symbol. But please keep in mind, it will not be the set of m such that m is greater than or equal to 3 or m is less than or equal to -5 because of the order. So we won't do it this way. Please don't do it that way. It will be marked accordingly on the test. And look at this. It should have been -5, and it should have been negative infinity to -5, and then 3 to infinity as we go through. So it's very particular when we're using this order. So please pay attention to that. Now, when working with set builder, right, in both set builder and interval notation, the set of all n that are less than 3 and greater than or equal to 7. Well, what numbers are less than 3 and at the same time greater than or equal to 7? Because I've got this situation. Well, I've got a null set here. And it seemed like a trick question, but you have to think about the questions as they're asked of you. The set of all x between -6 and -15, inclusive, which means includes this, including -15. Okay? And in set builder notation would be the set of all x such that -15 is less than or equal to x, which is less than or equal to -6. Please notice that I went from the lowest to the largest, although in the question itself, they did not do that. Okay? The interval of -15 to -6. Now this word inclusive means including -6, including -15. In example 8, express the following number line graphs in both set builder and interval notation. Now when we're looking at this in set builder, I have a closed interval at -3, open interval at -2. It's closed at -2 to 0 where it's closed, it's open at -2 to 0 where it's closed. And then it's open again from 1 to infinity. Now there's a couple ways for me to express this set. I'm going to write it down first for you. And I've got the set x such that -3 is less than or equal to x, which is less than -2. That represents that open spot. Because it's open, I have -2 is less than x and less than or equal to 0. So it goes from the open to the closed. And then it's x is greater than 1, which that's open, and it's greater than 1. So this represents all the possible pictures I've got up there, but I can write it another way possibly. What if I wrote it this way? The set x such that -3 is less than or equal to x, less than or equal to 0, where x cannot equal -2 and x is greater than 1, is an alternative way of writing the same answer. Now, we've used set builder notation. I want you to see what it looks like in interval notation. In interval notation, I start at a closed interval at -3, and I've got an open interval to -2. And then I start and another one at an open interval of -2 to a closed interval of 0. And then I finally end up with a open interval at 1 to an open interval at infinity. And that's an unbounded set. So this is what my interval notation for this set builder notation relationship would be. Now it's your turn. Give it a try for B. Turn me off and give it a try and then check my answers. Now in 8b, I have x such that x is less than or equal to -4. Okay, less than or equal to -4. And -3 is less than or equal to x, which is less than -2. Okay, x is equal to -1, and 0 is less than x, which is less than or equal to 2. Okay, now my interval notation would be -infinity to -4 closed, union, close -3 to open -2, union, close -1, close -1, union, open 0 to close 2. And that should conclude our notes for today. Okay, for day 1. I hope everything went well for y'all, and I'm looking forward to seeing you in class. Thanks and have a good day.